Okay, so this is going to be a lecture for topic 6.3, fuel types and uses, and again we're still looking at energy resources and consumption. Our goal is to identify the types of fossil fuels and their uses. We have a bunch of vocabulary terms in this section, and so we're going to go through all of those terms as we read. One of the things I want you to do when you're finished with this is I want you to go back and highlight the terms and in the notes so that we have them in context, because that's going to be really important for us. Okay, so our objective today is to identify the types of fossil fuels and their sources, and we're going to start out with biomass. So biomass is anything that was living or once living material, and we burn that and we get heat and energy and light from that. Examples of things that are biomass are things like logs, moss, dung, agricultural residues like leftover material from crops. This is developing countries, so economically disadvantaged countries have a high percentage of energy sources from biomass because they may not be connected to a reliable electrical grid. And biomass can be a renewable form of energy when used sustainably. And so we talked about that in our previous lecture, that we know that renewable resources are only renewable if they're used at or below the rate in which they can replenish themselves. So that's biomass. When we're talking about biomass, one of the things we have to talk about is peat. And peat is important into the formation of coal, which is one of our major energy resources. So peat comes from swampy material millions of years ago. And that swampy material can get compressed with heat and pressure over time, and it becomes peat. So we have plant material in swamps to become peat, and that's our first step in the formation of coal. And we can see that when over millions of years, as it's buried under water and dirt, that heat and pressure turns that eventually into coal. The next step in the process, so the second step in the formation of coal, is something called lignite. And lignite is also known as brown coal. And you can see, so, the plants become peat, sometimes called peat moss, and then over heat and pressure that becomes lignite, and then eventually lignite can become our two different types of coal. But all of those have to do with heat and pressure and water being expelled from the substance as that happens. So where are you going to find peat and lignite? You're going to find them in ancient swamps. Okay, so types of coal. There are two types of coal that we really focus on, and the two types are going to be bituminous coal, which is called soft coal, and anthracite, which is hard coal. And so again, realizing that as we increase heat and pressure, the amount of moisture is decreasing. So we go from not coal to brown coal to soft coal to hard coal, because that heat and pressure has condensed and pushed out the water. Peat we're going to find in swamps and bogs. Lignite we're going to find not as commonly, and then we've got bituminous and anthracite coal. So our three types of coal are lignite, which is brown coal, which is not a reliable source of energy. It has a lower heat content and a high sulfur content. Bituminous coal is our second type of coal. It's one of our vocabulary terms. It's a soft coal. It has a high heat content and a plentiful supply. But the downside to bituminous coal is that it has a high sulfur content. And we're going to spend a lot of time talking about sulfur whenever we're talking about coal. And sulfur is one of the main downfalls of coal. It leads to acid deposition and acid rain. And so we want to limit the amount of sulfur that we're releasing. So bituminous coal, although plentiful, is high in its pollution rating. The best type of coal is anthracite coal, or hard coal. And the advantage to anthracite coal is that not only does it have a very high heat content, it also has a low sulfur content. So it's a cleaner burning coal. But the downside to the anthracite coal is that it is not plentiful. It's limited in supply, and so it's a little bit more valuable because not only is there less of it, but it's a better fuel source. And so that kind of gives us our transition from peat up through anthracite coal, the advantages and disadvantages of each of those. Okay, so let's talk natural gas. Natural gas and crude oil are usually formed in the same places, and they're going to be formed from the remains of tiny ancient marine organisms. So whenever we think of coal, we're going to think of plant matter, but whenever we think of oil and natural gas, we need to think of ancient marine organisms. So we've got tiny sea plants, they die, they are buried on the bottom of the ocean floor beneath sand and silt and water for hundreds of millions of years, and we end up with this oil and gas deposit. Again, heat and pressure are going to be important in their formation, and so the oil and gas is usually together. The gas deposit sits above the oil deposit, and we're able to drill into them. Fun fact about natural gas: when we first kind of discovered fossil fuels, we used to burn off the natural gas because it was in the way of us getting to the oil, and then we finally realized, well, if we're burning the natural gas, we can use it. So how is natural gas formed? From the remains of tiny ancient marine organisms trapped under ancient oceans with heat and pressure. And what is natural gas used for? We use it for lots of things, any type of fossil fuel energy generation. So we can use it for heat, we can use it for power, we can use it for electricity, and we can even use it in combustion engines. Okay, so heat and energy sources. It is typically, the good thing about natural gas that I want you to kind of write down out to the side somewhere is that natural gas is a cleaner form of fossil fuels. So of coal, oil, and natural gas is the cleanest form because it burns the most completely. One of the byproducts of combustion is normally carbon monoxide, and it's the hazardous form of the carbon-oxygen compounds. But there's less carbon monoxide and less other impurities as byproducts when we combust or burn natural gas. So it is the cleanest of the fossil fuels, but it's still releasing CO2. And natural gas is methane. It's made up of methane, ethane, propane, and butane. But the primary component is methane, and we know that methane is a greenhouse gas. So if there is ever a leak from natural gas systems, it's going to have an even bigger impact on our, on climate change, because it's more potent than the CO2 is in terms of impacting it. So natural gas consumption, we can see here that 35% is used for electric power, 33% used for industrial power, 3% is used for transportation. A lot of mass transit and heavy equipment vehicles are moving toward natural gas, and we've got commercial and residential uses of natural gas. Okay, so transporting natural gas. Natural gas doesn't occur everywhere, and so we have to be able to transport it. And there are two forms that we transport natural gas. The first is LPG, or liquefied petroleum gas. This is what we're more familiar with here in the United States and in Okeechobee, because we are a rural area. It's mainly going to be propane and butane, so they kind of filter out the methane and the ethane. So you've got propane and butane, and it's used for shorter transport to rural areas. It does not have to be cooled as much, so you can see that it's cooled to negative 44 degrees Fahrenheit, whereas we're going to look in a second at liquefied natural gas, and it has to be cooled to negative 260 degrees Fahrenheit. So it's a little bit easier to do than the liquefied natural gas portion of it. With liquefied natural gas, or LNG, I always remember that LNG looks like the word long, and so it's used for long transport. We're talking from one country to another country here. It's mainly composed of methane, and it is cooled to negative 260 degrees Fahrenheit. So that takes a lot of energy to be able to cool something down, and then it's pressurized so they can fit a lot of it into these tankers. And since it has to be cooled, refrigerated, and kept at that really high pressure, it's incredibly costly. So we only use it when we're using really large quantities of gas that we're pumping places. Japan, for example, doesn't have any of its own natural fossil fuel sources, so it has to import its energy resources. And Japan imports a lot of liquefied natural gas, or LNG, from Russia to meet its energy needs. And so again, if we just remember that LNG looks like the word long, we know that that's for long transport of fossil fuels. Okay, so let's talk about crude oil. That term crude means not refined or natural. And so crude oil is just the natural state of oil when it's trapped in rocks. Again, it's the same process that we talked about when we talked about natural gas. The bodies of ancient marine organisms heated and pressed between layers of rock for 50 to 100 million years. We're going to find crude oil wherever we have ancient oceans, which is why oftentimes we find oil in our current oceans or in areas that were at one point flooded by oceans during different warming and cooling periods. Crude, again, means natural or straight from the earth. Whenever we talk eventually about oil spills, if it's a crude oil spill, it's not as catastrophic as a refined oil spill. Because since it's crude, it was created by nature. Nature has some system to handle it. If that oil has been processed by humans and become refined, then it's much harder for the earth to deal with it and break it down because it's not in its natural state. Crude oil, though, because it is crude and natural, is full of compounds and impurities that have to be removed before we can use it. And so we're going to talk about how we take crude oil and turn it into refined oil. So to take crude oil and turn it into refined oil, we're going to do a process called distillation. And so we take the oil out of the layers of rock, we transport it to a refinery. Once it gets to the refinery, they just heat it up. And they heat it up at set segments of temperature, and as they do that, different components will boil out, and that process is called distillation. And so, different compounds within the crude oil have different boiling points, and so we get things from asphalt to grease and wax to regular gasoline to aviation fuel, diesel. All of that, are the components of crude oil. They call those petrochemicals, and they can be separated out by their boiling points. That's the key here. Distillation is to separate out the components of crude oil by their boiling points. Once an oil has been refined, though, it does have more negative consequences because, again, since it's no longer in its natural state, it's a little bit harder for the earth to break it down and clean it up. One other thing that we need to note is that because we are heating this oil, we're going to have both air and water pollution created in the refining process. And once it's refined, it can then be shipped, and you can use it either for heating or for gasoline. Okay, tar sands, which are also called oil sands, but we're going to refer to them as tar sands, are another form of fossil fuels. It's just one we're not as familiar with. Basically, it's sand and water mixed with a hydrocarbon, so a carbon-based compound, and the fossil fuel type that's in tar sand is called bitumen. We're going to find tar sands under ancient coastal forests. It forms very similarly to the way that oil forms. It's just not as deep underground because you're going to find it, closer to the surface. We have a lot of tar sand in in parts of coastal Canada. So what they have to do is they have to remove all the vegetation, scrape up the soil that covers the tar sand, and then they take it and they heat it and they wash it to separate the bitumen oil out of the water and sand. This process is incredibly thirsty in that it uses a lot of water. To get 1 barrel of oil, bitumen oil, you're going to use over 4 barrels of water in the processing. So this is a very, very water polluting, water using process. It also has a high air pollution cost in the heating process. I don't know what I was doing when I was writing this. But because it has to be heated so much in order to separate out the oil from the water and the sand, we're going to have a lot of air pollution released, and it destroys forest and coastal ecosystems because they have to scrape those areas up. So you can see here that we have both water, sand, clay, and the bitumen, and they've got to separate out the bitumen oil from the rest of the tar sands. And so here's just some pictures of Alberta, Canada. This is what Alberta, Canada's coastal forest should look like. This is what the area will look like after they have mined for the tar sand. You can see they've removed all the vegetation. So we lose all of the benefits of the forest, the habitat, water purification, air purification, biodiversity, soil erosion protection. All of those things are lost in the mining of these tar sands because they have to do the mining process as like area strip mining. And so it's very devastating to ecosystems. Okay, shale oil, almost done. It's our kind of last little bit of fossil fuels. Shale oil is basically oily rock. And so it's rock that contains a hydrocarbon called kerogen. And we have a lot of this in the Midwest United States, like a lot of it. The problem is that you have to crush tons of rock in order to get just one barrel of the kerogen oil. So you extract the rock, you crush it, you heat it, and that process usually results in a negative energy return. And what that means is that it takes more oil or fossil fuels to extract, crush, and heat than it does for you to get out of that amount. So currently it's not really a feasible form of energy, but potentially it could be. We do use this also though with hydraulic fracturing or fracking. So this is the same type of oil that we could do this in, where we push the fluid into the oil, crack it in place, and then suck the oil out of that rock. And so we can do hydraulic fracturing or fracking in this process. And so just kind of as a reminder of what happens with hydraulic fracturing, pressurized liquid is forced into the rock, breaks it to release the shale oil. The oil and the fracking fluid are pumped back to the surface, and then we separate them. Just like we've talked about before, there's a water pollution risk with this because of the substances that they're putting down into the rock. And then also we talked about how there may be a connection to earthquakes as they are lubricating these ancient peels within tectonic plates. Okay, but that's shale oil, and shale oil has kerogen. Okay, so fracking for shale oil, this is just kind of an image of what they're doing. So we're going to pump the fluid down into the shale. It's going to split the rock into pieces, and then we can pump out the gas or oil back up to the system and then refine it. And then we can, take and seal that rock later, or seal that solution in the rock later. But there is a concern about the impact to the water supply. And so on the actual video, or on the actual presentation link, you'll see two videos. And I want you to watch the two quick little videos about what fracking does, and then how fracking may or may not be connected to a rise in earthquakes in the Midwest United States. Okay, last question. Cogeneration for heat and power. Sometimes this is called combined heat and power, CHP, but the key here and the term that they're going to use for your APES exam is going to be cogeneration. So basically what happens is, we know when the second law of thermodynamics that whenever we convert energy or transform energy, some of it is always lost as heat in the process. And so what we're doing here with combined heat and power, or cogeneration, is we say, okay, well, let's generate electricity like we have been doing, but instead of just allowing that heat to dissipate into the atmosphere, let's collect it and let's pump it into nearby buildings for them to use as heating. And so it takes the efficiency of the system from about 30%, which means 60% of the energy would be wasted, just to making the surrounding area hot. Let's channel that into surrounding buildings, and then the efficiency of the system becomes almost 90%. So this maybe not the greatest for, say, South Florida, but could be really, really helpful for areas that need heating for most of the year. Okay, so let's take a second before we talk about your textbook. Let's just make sure that we know what we're doing. So can we identify the types of fossil fuels and their uses? We know when we look through that vocabulary, I want you to flip back to the vocabulary really quickly, that wood is one of the primary examples of biomass. Fossil fuels, biomass energy, that it can be renewable, but that it's actually one of the connections to employment and education for girls, because if the area is reliant upon wood for energy, women and girls often spend most of their day collecting wood, and therefore lowers the literacy rate and the employment rate, which increases the population. Peat, we know, is the first step in the formation of coal. Biomass we just talked about as material from living things. Lignite is the second step. It's the brown coal. Bituminous is the high availability but high sulfur content coal. Anthracite is the hard coal with the least amount of water in it, the least amount of sulfur, but also the least available. We talked about natural gas and how it's formed from the deposits from ancient marine organisms in ancient swamps, and it can either be transported in rural areas through LPG, or long distances through LNG, LNG mainly being methane. Talking about methane, we know that methane is also a greenhouse gas, and so we have to be aware that we can combust methane in order to get, heat and release carbon dioxide. But if that methane, if there's a gas leak, it's going to be more potent in impacting climate. We talked about how crude oil is found beneath natural gas deposits, again from ancient marine organisms, and we can take that crude oil and we can refine it, separate it out into its different parts through the process of distillation, which is using the boiling points of the different substances. Tar sands, we know, are found in coastal forests, and it's very detrimental in terms of water quality, air pollution, and what happens to the ecosystem as we scrape all of those trees away to do some area strip mining. Bitumen is the type of hydrocarbon or fossil fuel found in tar sands. We know that shale oil is that oily rock, and that rock has to be crushed in order for the kerogen, or the fossil fuel oil trapped in the rock, to be removed, but that can be done through fracking. And then lastly, we talked about cogeneration and how cogeneration can take the efficiency of the system from, say, 30% up to 90% by combining the electricity production, the power production, and funneling the heat that would normally be wasted from that to warm nearby buildings. Okay, so this textbook connection has several pieces to it. 14.2, 14.3, and 14.4, because the textbook kind of breaks each of those areas down. And so I want you to read through those pages. I want you to answer the checkpoint for understanding questions for each of them. And remember, these would all be done on the checkpoint for understanding questions for chapter 14. So you've already got 14.1 done. Now you're going to go in and do 14.2, 14.3, and 14.4. And then if you find anything as you read that you feel like you should add to your notebook, I want you to add that to your notebook. Okay, once you get to your activity page for fossil fuel types and activities, what I want you to do is divide the page into the 5 types that we talked about: coal, oil, natural gas, tar sand, and shale oil. So you can just divide it into those 5 boxes. And then for each of them, you're going to draw how it's formed, including what it came from, because it's important that we know that coal came from plants, but oil and natural gas have come from marine organisms. Show how it's extracted, so show me some sort of mining process, and then tell me 2 environmental consequences of the extraction or refining process. In this, I want you to try to go back and use all of your vocabulary terms, because we want to make sure that we have practice to them, and you should add color to your drawing. So I want to see 4 or more colors on this activity page. Okay, so that concludes topic 6.3, which is fuel types and their uses.